welcome to Learn TT. My name is Praise, and in today's class we'll be talking about bearing. In our previous videos, we've talked about bearing, angle of elevation, and angle of depression. And today's class will also explain much more about bearing while solving examples on it. Now, bearings are the clockwise angular relationship between two distant places which are measured in degrees. Bearings are the clockwise angular relationship between two distant places which are measured in degrees. Now, the bearing of an object P from O is the angle from which OP from O is the angle which OP makes with ON in the clockwise sense. What do I mean? When we have something like this, here we have our N, this is our O, this is E, this is W, and this is S. Here we have our four cardinal points to be north, south, east, and west. So we have this angle from line P. Now, the bearing at which P makes from O is the angle from which OP makes with ON. Now, this OP, the angle OP here makes with O at the center, is the same angle in which ON makes with O at the center, just like this, that the angle here that made this so as T, that OT makes with O at the center is the same angle that OE makes with O and with the which is the angle at the center. And today we will solve examples on bearing. Now, our first example says that a tree is on a bearing S 36 degrees west. From a point X, and S 78 degrees east from a point E. Now, if X is 200 meters due east of Y, calculate the distance of the tree from Y to the nearest meter. If X is 200 meters due east of Y, calculate the distance of the tree from Y to the nearest meter. Now, we have this here, we have S and west, and we have S and east. So, when we have something like this, so we have our diagram to be something like this. This is north, this is east, this is west, this is south. When we have 36 degrees of west, we have here to be 36 degrees, and we have it to be 78 degrees of east. So 78 degrees will now be this. Now, our X between them is 200 meters. So here we have it to be 12 degrees, and here we have it to be 54 degrees, which is the angle in a right, sum of angles in a right angle triangle. So we can have it now to be X, we have our XYZ will now be 90 degrees minus 78 degrees. So we have our 90 degrees minus 78 degrees to be 12 degrees, and we have 90 minus 36 to be 54 degrees. Now, to get this angle here, we know that sum of angles in a triangle is 180 degrees. So we now have it to be 180 minus 12 plus 54. So here will now be 180 minus 66. So 180 minus 66, we have it to be 114. We have it to be 114 degrees. So here we have it to be 114 degrees. We have it to be 114 degrees. So basically now, using our sine rule to calculate the distance from the tree from y. Now, to calculate the distance, we use our sine rule where we have x, t, and y. We have x, t, and y. So basically, here can be, we have here to be our t, we have here to be our x, and here is our y. So we now have it to be x over sine x equals to t over sine t equals to y over sine y. So we have it to be x over sine x equals to t over sine t equals to y over sine y. So when we have this, we will now use our x over sine x, where we now use our t, which is 200 over sine 100 minus 114. So we now have it to be x over sine 54 equals to 200 over sine 180 minus 114. So when we add this, when we solve it and making the x a subject of formula, we have it to be 200 sine 54 over, this will now be sine 66. So we have it to be sine 66, and we make our x. Solving this, we now have it to be x, which is 177 meters. So our x here is 177 meters. We have our x to be 177 meters. We have our x to be 177 meters. Now, solving our next example, we have two ships, A and B, leave a port at the same time on bearing of 159 degrees, and B travels on a bearing of 215 degrees. After some time, A is 9 kilometers from P, and the bearing of B from A is 256 degrees. Calculate the distance of B from P. So basically, one is starting at 159 and the other is starting at 215. So we have it to be 215 equals to 159 degrees. Now, for that 159 degrees, we will now do 180 minus 159 degrees. So we have it to be 180 degrees minus 159 degrees. And here we have it to be 21 degrees. we have 21 degrees. Now it says A is 9 kilometers from, and the bearing from P from A is now 256. Now the 256 degrees, we now add it to our 21 degrees. So we have it to be 256 plus 21 degrees to give us 277 degrees. We have 277 degrees. So here we now have it to be, but before that, let us make our diagram to enable us to understand much more better. So here we have this. Here we have this, where we have angle of 215. We have 215 to this place. So we have this. So here is 215 centimeters. So here we know we have 189 and 159. So here is 159 and here is 21 degrees. So here where we have 21 degrees, the other part here, so here we also have 21 degrees. Now for our 21 degrees, we already have it like this, and here is 9 kilometers. We have 9 kilometers. Now, continuing further, we now have it that 360 minus our 277, because we have 180 minus 159. So we have 360 minus 277. We have it to be 83 degrees. We have it, so our 83 degrees will come around this side. So we have our 83 degrees to be at this point here. So here can be our 83 degrees. So I'll just come here. And 159 plus 121 for here, we get our 215 plus our 56 degrees there. So where we have something like this. So here is 215 degrees. So we already have our 83 degrees. So here we now have it to be 180 minus 83 plus 56. So here is 56 degrees to get our 215 from the earlier start, where we get 15, because here this is 90 plus 90, this is 180, and here is extra 35 degrees. So 35 degrees here plus 21 gives us our 56 degrees here. So we have our, so this angle here will now be sum of angles in a triangle. So we have 83 plus 56 to be 139 degrees. And sum of angles in a triangle will now be 180 degrees minus 139 degrees. We then have this to be 41 degrees. We have it to be 41 degrees. So here is 41 degrees. So we have 41 degrees here. So using our sine rule, to find the distance of B from P. You know our question is to calculate the distance of B from P. Then we use our sine rule, where we now use A over sine A equals to B over sine B equals to P over sine C. So basically we can just use A over sine A. Then we have our 9 kilometer over sine 91 kilometer. So we have equals to, we have 9 over sine 41 degrees. Sorry. So when we cross multiply here to find our A, we now have it to be 9 times sine 83 over sine 41. So we have our A to be 9 times sine 83 over sine 41. So here, our A, solving this using a calculator or the logarithm table, we have our A to be 13.61 degrees. We have it to be 13.61. Sorry, it is not in degrees. So our A here is now the distance from B from P. So our A here is 13.61 kilometers. 13.61 kilometers. And this brings us to the end of our class today on bearing, where in our next class we also solve more examples on bearing. Do subscribe to our YouTube channel, like and comment, and I'll be seeing you in the next class. Thank you.